Okay, now we're moving on to arc length in the area of sectors. You did do some of this in geometry, but we're going to add in how to find them with radians. Just as a reminder, a circle with a center, and then we can make a central angle here, which is where theta is, and arc length is how long that is. So it's a length of measurement. And now an area of a sector is the same idea. Sorry, these are both radiuses. The same idea with a radius, and theta is here. But the area of a sector is what is the inside of this region. What is the area, which is in squared units. So arc length is a length that's one-dimensional, and area is squared units. Okay, so the formulas that you hopefully already know is the arc length is equal to the circumference formula, so 2 pi r, and the part of the circle out of 360 that we're talking about. And we know that area of a sector is based on the area of a circle, so pi r squared, and also its portion of the circle. Now, the radian degrees are a little bit different, or the formula is for arc length, we're going to use the angle measure, which is in radians, and the radius. So, pi over 3. 2 pi over 3. Pi over 4. Those are our radians. And then my area formula is a little bit different. So it's 1/2 the angle measure in radians times the radius squared. So those are the new formulas that we're going to use. Okay, the directions here said find the major and minor arc lengths and the major and minor sector areas given by the image below. Well, I can see the minor arc, and it tells me that BOA is pi 3. So this is how many radians that is. So it is a minor arc. Remember, a minor arc, is when the angle measure is less than 180. And a major arc is greater than 180 degrees. So this is a minor arc. It's definitely by their drawing. We know that it is less than the 180. Tells me CO is right here, and that's the radius of 4. And then CO and OA are congruent, so that's also the radius, which is 4, which makes this side also 4. So we have all the sides of 4. Now to find the minor arc length, I'm going to use the length is equal to theta times the radius. So the length is equal to pi over 3 times the radius of 4. So this is just 4 pi over 3. Is that exact answer? Then this is just a calculator. We're doing that right now, but we will not do this very often. It's 4.1889 units. We didn't give you the units, so they are units long. Okay, so I'm going to go stick with the minor. So I'm going to find the area of the minor. So the area of the minor is 1/2 of theta radius squared. So area is equal to 1/2, and that is pi over 3, and the radius is 4 squared. So now we're just doing the math with this. So 4 squared is 16, half of 16 is 8. So this is 8 pi over 3 units squared. And then the approximation is just in your calculator. That's 8.3776 units squared. Now, what we don't have a picture of is the major arc. So this is saying the circle continues all the way around. That would be your major arc. And if this is pi over 3, then I would do 2 pi minus pi over 3. And that is a denominator of 3, so that would be 6 pi over 3 minus pi over 3. That's 5 pi over 3. So that is what my major arc is going to be for that one. So now for the length of the major arc is equal to that 5 pi over 3 times the radius of 4. So that is just top times top, bottom times bottom. So that's 20 pi over 3, and that's units. And now the approximation is about 20.9440 units. And now the area of the major arc is that 1/2 the measure of the angle, the theta, is 5 over 3, and the radius is 4 squared. So now I just do 4 squared is 16, half of 16 is 8, so that's 40 pi over 3 units squared, and then that is 41.8879 units squared. So that's how we just use those formulas straight up. Okay, find the length of an arc and area of a sector formed when the radius is 3 and theta is 120. So they're giving me degrees, so I'm going to use my degree formulas, which is 2 pi r, and the measure of the angle over 360. And then area is pi r squared, and the measure of the angle over 360. So those are the two formulas we're going to use. So length is equal to 2 pi, the radius is 3, and it's 120 over 360. Well, that's 1/3 of a circle. So I think about 2 times 3 times 1 over 3 and pi. All I did was put that fraction in there. So that's 6 divided by 3 is 2 pi, and these are centimeters. Okay, so for area is pi with the radius of 3 squared, and it's times 120 over 360. So this becomes pi times 9 times 1/3. So now 3 goes in, 9 divided by 3 is 3. So this is 3 pi centimeters squared. Okay, so this tells me a sector has an arc length of 18 pi inches and a central angle, that would be theta. Find the radius of the sector and its area. So it's giving me in radians, so I'm going to use my length of theta r, and the length is 18 pi, and my theta is 9 pi over 8, and I'm looking for the radius. I'm going to multiply by the reciprocal, which is 8 over 9 pi. So that gets my r by itself. And now the pi's are factored out. 9 goes into 18 twice, so 2 times 8 is 16. So my radius is 16 inches. Now I'm going to use the 1/2 theta r squared to find the area of the sector. So the area is equal to 1/2. Theta is 9 pi over 8, and the radius is 16 squared. Okay, so now I'll put all my numbers together. 1/2 times 9/8 times 256 over 1 pi. Don't forget the pi. Now 2 goes into 256 128 times. 8 goes into 128 16 times. So 16 times 9 is 144 pi. So it's 144 pi inches squared. Okay, so this one says a sector has a radius of 4 and an area of 12 pi meters squared. I've got to find the central angle, which is the theta, and the arc length, which is the L. So I'm going to start with my area formula of a sector. So A equals 1/2 theta r squared. So 12 pi equals 1/2 theta 4 squared. So 12 pi equals 1/16 is 8 theta. Divide both sides by 8. So my theta is going to be 3 pi over 2. So 3 pi over 2 is my theta. Okay, so now we want to take that and find our arc length. So length is equal to theta radius. So length is equal to 3 pi over 2 times 4. So this reduces, so my arc length is 6 pi. So 6 pi meters. Okay, sector has an area of 60 pi kilometers squared and a central angle of 5 pi over 6, so that's theta. Find the radius and the arc length. So I'm going to use area is 1/2 theta r squared. So 60 pi equals 1/2. Theta is 5 pi over 6. Do not have r squared. So I'm going to condense this down and get 60 pi equals 5 pi over 12 r squared. I'm going to multiply both sides by 12 over 5 pi to get r squared by itself. And r squared, 5 are going to there 12 times. So, and the pi's factor out, so that's 144. The square root of 144 is 12. So my radius is 12 kilometers. Now I need to find my central angle. Oh, now I need to find my arc length, sorry. Now I need to find my arc length. So my arc length is theta times the radius. So my arc length is 5 pi over 6 times the radius of 12. So my arc length is 10 pi. So it is 10 pi kilometers. Okay, this one's a little bit different. It's telling me the area is 60 pi millimeters squared and the arc length is 10 pi millimeters squared. And I'm looking for radius and central angle. Well, I know that the arc length is equal to theta r. I know that area is 1/2 of theta r squared. But I can also rewrite that as 1/2 theta r times r, because I'm just multiplying those together. So I can now replace that 10 pi. So we know that the arc length is 10 pi, and that's what theta r is. So I'm going to put 10 pi there. So my area is 60 pi. 1/2 theta r is 10 pi, and I'm looking for that radius. So 60 pi equals 5 pi r. Divide by 5 pi, r is 12. And now I'm going to use my length of 10 pi equals theta 12. Divide, because that's the easiest formula to use. So theta is equal to 5 pi over 6. Okay, sector has a radius of 12 nanometers and an angle of 11 pi over 6. Find the arc length in sector. I've got everything that I need. I've got r equaling 12, and there's my theta. So the length is equal to theta r. The length is equal to 11. Oh, see, I always do that with 11. Oh no. 11 pi over 6 times 12. So my length is 22 pi nanometers. Okay, so now let's go and find our arc area of our sector. So that's 1/2 theta r squared. So area is equal to 1/2. Theta is 11 pi over 6, and my radius is 12. So half of 12 is 6. 6 is on the bottom. So my area, 12 squared. So that's 1/2 times 11 over 6 times 144 over 1 pi. Just put all the numbers together. 2 times 6 is 12. 12 goes to 144 12 times. So 12 times 11 is 132 pi. So this is 132 pi nanometers. Okay, this one says a two-dimensional sector below is manipulated into a three-dimensional cone. So we start with this apex view of a sector, and they're manipulating it into the cone. So we're kind of look at this. This is my angle theta. This right here is my radius, but this is going to convert into that slant height, which is here. So my slant height here is my r. I know that the height of the cone is 3. I know that they tell me the diameter here is 8, so that makes my radius 4. And now if you know your triangles, we know what r is, but 3 squared plus 4 squared equals r squared. 25 equals r squared, so r is 5. So I have a 3, 4, 5, so I have my radius. Now to find the circumference of the base, I can go and do 2 pi r, and so that is 2 pi 4. So the circumference is 8 pi. And now I know that that is the length of my sector. So now I'm going to take my 8 pi and set it equal to my arc length, and so when I solve this, this is a 5, so 8 pi equals theta 5, divide by 5, so it's 8 pi over 5 is my angle measure. So my radius is 5 centimeters, and theta is 8 pi over 5. Okay, so this question is showing us part of a road with curves or arcs of a circle. Find the length of the road from point A to point E, given the following information. So I'm looking over here at A to B, and I need to find the length, and I'm given a degree measure, and I'm given a radius. So I'm going to do my length as being 2 pi, 1.5 is my radius, and 85 over 360 is my arc length. I'm going to go ahead and just put this in my calculator, and this gives me 17 pi over 24. So this is 17 pi over 24. This is 3.75 miles. Now I'll do this center portion. So this is also my length is equal to 2 pi. The radius is 2.25, and 60 over 360. I'm going to stick that again into my calculator, and this gives me 3 pi over 4. And then that's the other length. So I'm just going to add these up. I'm going to add my 17 pi over 24, the 3.75, the 3 pi over 4, and the 5.45. Put that into the calculator, and then we're going to round it to the 10,000ths, and this gives me 13.7815 miles.